Neptune. Gas giant, an ice giant, the farthest planet in our solar system, beautiful ocean world, the blue pearl of our solar system. What do we actually know about this planet? Let's go through the most common questions about this planet and learn everything we know so far about Neptune. When we talk about Neptune, we always think about Uranus and Neptune as the twin brothers and the farthest, outermost places of our solar system. However, if you think about the location of the Neptune, it's much further than the Uranus, and although they're classified as similar planets, Neptune is quite different from the Uranus. So the first question usually people ask, is that the Neptune the furthest planet we know in our solar system? And there's always confusion coming from remembering about the Pluto. Let's start from the discovery of the Neptune. The Neptune was discovered soon after the Uranus in 1846, and for almost 100 years it was the furthest known planet. But in 1930, the scientists discovered Pluto. And that time they were sure this is the 9th planet of our solar system. And the Neptune became the second furthest known planet, number 8 between Uranus and the Pluto. For 20 years, from 1979 till 1999, we observed that the Pluto came closer to the Sun than the Neptune, following its elliptical orbit. And that time the Neptune was considering the 9th planet of the Sun. We progressed our knowledge about the solar system, and with the help of Voyager trips and more sophisticated telescopes in the 90s, people discovered the Kuiper belt. See about the Kuiper belt my video on the age of our solar system. And from 1992, there became a big debate. Is the Pluto actually the planet, or the little dwarf planet that came from the Kuiper belt? And if we look closely to its elliptical orbit, science decided that the Pluto, which is even smaller than our moon, must be a dwarf planet. In 2006, International Astronomical Union defined the word planet for the first time, and this put the Pluto into category of dwarf planet, and the Neptune again became the outermost known planet in the solar system. So here we go. The Neptune was the further known planet of our solar system, number 8. Then it's become the 9th planet when the Pluto was in the game, and now from 2006, again, it's the furthest known planet of our solar system, and it's standing after the Uranus. Can you observe the Neptune today and how it was discovered? Unfortunately, if you look in the sky, the Neptune will look like a star for you. Even in your average home telescopes or binoculars, you couldn't precisely observe the disk of the Neptune. Only modern, sophisticated and more professional telescope can show you the Neptune as a disk, blue disk on the sky. That's for long times the Neptune was considered to be a star, a distant star. After the discovery of Uranus, watch my video about the Uranus, French astronomer Alexis Bouvard spent a lot of time trying to observe the orbit of Uranus and calculate it. And he detected a gravitational perturbation that he decided could be only explained by the existence of another planet affecting the path of the Uranus around the Sun. And soon after, other astronomers calculated the location of Neptune. We cannot pinpoint which one exactly first discovered the Neptune. Neptune was actually spotted before by Galileo Galilei, almost 200 years before. However, he was considered it as a star. For the first to look at Neptune and understand what he was seeing using calculations from French astronomer Leverrier. And soon after, this planet was given a name, Neptune, following the sequence of Roman gods. Neptune is quite a big planet. it's 17 times mass of our planet Earth. However, it's so far away. If you think about the distances, it's about 30 astronomical units away from the Sun, which means it's 30 times further than our own planet from the Sun. It will mean that Neptune received 1 of 900ths of the energy from the Sun that the Earth received. And the Neptune's orbit is very big. It rotates around the Sun on a distance more than 4.5 billion kilometers away. Neptune is one of the 4 gas giants, and it's also called Uranus' twin. And this leads us to the next common question. Is the Neptune actually the planet full of ocean? Because of its name and its beautiful blue color. If we look closely on both Uranus and the Neptune, they slightly of different blue color. And despite the similarities of these 2 ice giants, they have quite different characteristics. Technically, yes, the Neptune is the planet of the ocean, however not in a sense that we imagine, knowing our own planet. In fact, we can say the Earth is the only planet in our solar system which could be called the ocean planet. Because of this enormous distance from the Sun, the ice giants Uranus and Neptune are slightly different from the Jupiter and Saturn. They're mostly made of hydrogen and helium, with ices of water, methane and ammonia surrounding an icy rock core. And this methane content gives Uranus this blue-green color, when Neptune is a little bit of brighter blue. Scientists are not sure what exactly gave it such a color. There is definitely something in the atmosphere that gives it this specific deep blue color. Let's look at Neptune's composition. A gas giant, but it's not solely comprised of gases. Its core contains silicate rock, iron and nickel, and is a little larger than planet Earth. It's just a core. There's an enormous great pressure, twice as much pressure than in our own Earth core, and there's about 5,100 degrees Celsius temperatures there. This enormous pressure is surrounded by the thick icy mantle. However, in such densities, it's not like ice as we imagine on the surface of our Earth. It's actually a strange combination, hot combination of dense liquid, made of methane, ammonia and water. The mantle is electrically conductive, and its temperature ranges between 1,700 degrees Celsius to 4,700 degrees Celsius. There is also additional layers, including a layer of ionized water and a deeper layer of superionized water. And of course, when we look to the Neptune, we see this beautiful color, some spots of swirls and some white clouds. This is all happening in the atmosphere surrounding the mantle. The atmosphere for 80% composed of hydrogen, 90% of helium, and the rest it's the ammonia and water and methane. The mostly methane responsible for the spectrum of the light that we see on the Neptune. Scientists are not sure, and they're suggesting there's something else in the atmosphere that make it Neptune of this bright blue color rather than the Uranus bluish green. We observe the troposphere and stratosphere, the divisions in the atmosphere, and probably in troposphere there are different types of cloud bands there, depending on where they're located. And the low-level clouds will be hydrogen sulfide and ammonia. There's a water ice clouds, and the temperature drops, and the pressure increases. In the uppermost layers of the troposphere, clouds are ammonia and hydrogen sulfide. We see the bands of those clouds wrap around the planet, and we see the shadow of them casting on clouds below them. The next question comes to the mind, is the Neptune the coldest planet in our solar system? Because it's furthest located, it's on 50% more distant from the Sun than the Uranus. Instead of 19 astronomical units, it's located 30 astronomical units away. And it's have similar composition, therefore we would think it should be colder than Uranus. However, it's not quite like that. In average, the Neptune is warmer than Uranus. The stratosphere has traces of carbon monoxide, and the thermosphere is unusually warm. And it's unusual for the Neptune because it's distance from the Sun. However, we recorded that the planet radiates more than twice times more energy than Uranus, although it's received 40% less of sunlight than the Uranus. And the surface temperatures observed almost same like for the Uranus. We already talked about the reasons why the Uranus could be much colder than the Neptune. Check it in my video about Uranus. And it's related to the history and collision of Uranus with the body in the first years of its formation. Check out my video about the Uranus to learn more. However, Neptune is different from the Uranus. We have very pronounced storms we observed there, and the first explorer of the Neptune who fly by, Voyager 2 in 1989, sent us the images of those storms, resembling the storms on Jupiter. And scientists suggested now that on the Neptune we have the storms and the winds that 4 times stronger than the fastest winds on our planet, given that this speed reaching the barrier of the sound speed. These winds reaching 2,000 kilometers per hour, and they're the fastest in our solar system. Most of those winds blow in retrograde rotation, so it means it rotates in opposite direction than the planet's rotation. In general, it's prograde rotation in direction of the planet rotation in the higher latitudes and retrograde rotation in the lower latitudes. The Voyager 2 first observed weather phenomena on Neptune during its flyby in 1989. It was not comparable with Uranus. It observed a massive anticyclonic storm that was 13,000 by 6,500 kilometers in size. It was dubbed the Great Dark Spot. 5 years later, the Hubble Space Telescope viewed the planet, and he didn't see this spot, but another storm was found and given the name. Neptune also has the largest storm named the Scooter and the Small Dark Spot, the ones that resemble the red spot on the Jupiter. The Neptune storms, including hurricane-force winds, constantly blow around the planet. Voyager 2 also recorded the variations in temperature in the Neptune atmosphere and discovered additional rings around this planet and the moons. This violent weather on the Neptune suggested to be due to its higher internal heating, because the depths, the atmospheric pressure is very high, going down through the layers of the gas, temperature steadily rising. Yet some scientists suggested that can explain this anomaly with the fastest wind on this planet, due to its contrast of the internal heating and the cold in the outer layers of atmosphere. The Neptunes travel around our Sun longest than any other planet, in 164.8 years. We know that on 11th of July of 2011, Neptune completed its first full orbit since its discovery in 1846, and didn't appear in exact discovered position in the sky, because Earth was in a different location that day. The axial tilt of Neptune is similar to the Earth, about 28.3 degrees. On the Earth it's about 23 degrees and on Mars 25. And it means that Neptune experienced similar season changes, like on Earth. However, they're much longer. They last about 40 years. I cannot imagine to live through the winter of 40 years. And you? Although it would be nice to have 40 years of spring and summer. But it rotates around itself very fast, about 16 hours. I feel like our day is 24 hours on our planet, very fast. On the Neptune, it's much faster. The next question about the Neptune, it's about its rings. Do you imagine Neptune with rings or not? Usually not. Usually we don't think about Neptune rings. However, there are rings, and there are many of them. And they're very unusual than any rings in our solar system. Its ring system was first spotted in 1984 in Chile by a group of international astronomers. Prior to this, astronomers suspected rings when observing dips in the brightness of the stars viewed between the observer and the planet. However, as we learned later, these rings are very faint, very thin, and composed of very dark material. That's what makes them very hard to see. Voyager 2 take photographs of these rings, and we see the good bright rings now using the Hubble Space Telescope, as well as the Earth Space Telescopes. There are 5 distinct rings, named in order of the distance from the Neptune: Galatea, Leverrier, Lassell, Arago, and Adams. As you can hear, this is the names of the first explorers of the Neptune, those who discovered it on the sky. Gale is the very faint ring, named after the first astronomer to view the planet. Leverrier is extremely narrow, just about 113 kilometers wide. Leverrier may be confined by the moon Despina, which orbits just inside it. The widest rings, Lassell, is also called the Plateau. It's a thin sheet of dust stretching from Leverrier to the next ring, Arago. Arago doesn't look like a ring at all, it just looks like a rim around the edge of the Lassell, and it's less than 100 kilometers wide. The best studied it's the Adams rings, outermost ring. It's a narrow ring, slightly slanted. We notice the perturbations in the rings, like a wiggles, at the 42 different places, made by shepherd moon Galatea. There's also unusual features in the Adams ring. 5 bright spots called arcs located along the ring, where these particles of dust are clustered together. They differ in brightness. They were discovered before the Voyager, just before the Voyager by the telescopes, and the Voyager 2 confirmed their existence. Since the discovery, they seem to move slightly and dimmed, although they're still there and they could be observed. We're just unsure why these dust particles have clustered together in those areas. Probably there will be undetected moons or moonlets, or maybe arcs could be caused by unusual resonance with the moon Galatea. Therefore, the rings of the Neptune so unusual, so strange, and a little bit different from any other rings in our solar system. What about the Neptune moons? Does the Neptune have any moons or the satellites? Yes, Neptune does have the moons, and they're all named after the water deities or the water gods, just because the Neptune, it's all about the ocean. And probably you know the most famous, the moon or the satellite of the Neptune is Triton, and it's by far the largest moon, comprising more than 99% of all total mass that orbits around this planet. For today, people note about 13 known moons. And Triton suggested to be probably a dwarf planet in the Kuiper belt. They've been captured by Neptune's orbit. Why so? Well, first of all, it's 2.7 Sun kilometers in diameter, and it moves in retrograde orbit. It circles Neptune opposite of the planet's rotation. It's have a regular orbit, and is the second known moon to have an atmosphere after the Saturn's moon Titan. Therefore, in the Neptune, many are more interested maybe in the Triton more than Neptune itself. It has atmosphere, it's mostly comprised of nitrogen, with some traces of carbon monoxide and methane. And it's as well one of the coldest objects in the solar system. The moon is very dense, and it's probably 2/3 rock and 1/3 ice. Triton is one of the 7 outermost moons which have irregular orbits. Next moon to be discovered, Naiad, in 1949, is the 3rd largest moon, unlike Triton, and has a prograde orbit. Its orbit is also extremely eccentric, and it's varied from 1.2 million kilometers, the closest to the Neptune, to 9.6, the furthest from the Neptune point. Probably Triton affects its orbit, and probably it was as well the object as a Triton come from the Kuiper belt. Sao and Laomedea have prograde orbits as well, and so regular moons, and were discovered in 2002. Halimede, Psamathe, and Neso all have retrograde orbits. They were discovered in 2002 and 2003. It's far away orbits from the Neptune, and they orbit about 48 million kilometers away from the planet. 6 inner moons have regular prograde orbits: Naiad, Thalassa, Despina, Galatea, and Larissa, and Proteus. We don't know much about 4 innermost moons, when we know that they're small and of a regular shape. Probably they formed from the debris left over when Triton was pulled into orbit. Naiad is the innermost moon and was discovered by Voyager 2. Thalassa was discovered around the same time, and the both moons orbit between 2 rings, Gale and Leverrier. Despina is the 3rd closest moon, and Galatea may serve as the shepherd moon, holding the Adam's ring in place. We talked about shepherd moons in a video about Saturn and Uranus. Larissa, the 4th largest moon, was discovered in 1981. It's about 200 kilometers in diameter and have elongated shape. It's heavily cratered, and next after it goes the Proteus, the 2nd largest moon that orbit around the Neptune. It was also discovered by Voyager 2, and we know it's about 400 meters in diameter, with a lot of craters on its surface. There are probably more moons to be discovered, but more important to learn about where this moon come from, what role they play during the formation of the planet or after, and it leads to the next interesting point of the interaction of the Neptune with the Kuiper belt. Neptune's gravitational pull has an impact on the Kuiper belt, and we know it because of Pluto effect and those moons that have been attracted by the Neptune, like a Triton. Neptune's gravity has destabilized areas of the belt, and it's also created a resonance between the planet and at least 200 of the objects. But this will be the topic of the next video, about the Kuiper belt and what lies further or way outside of our planet systems. If we think about evolution of the Neptune, both Uranus and Neptune suggested to be planets that migrated to their current position, and these interactions of the Neptune and the Kuiper belt could happen since then. Why we think so? The idea is that the planets like Neptune and Uranus could not form at the position where they're now. They shouldn't be formed somewhere closer to the Sun and then be migrated to the position that they're taking right now. Scientists explaining there should be not enough material at that position at the time of formation of the solar system to form such ice giants. We can talk about this in the next videos, and I hope you have a good impression of this ocean giant rotating so far away from us and our Sun. Please subscribe, like my videos, and share them, and I see you in the next video.